Check my audio levels real quick. Okay, audio check, test, test. Yes, there is an audio delay between when I speak and when it shows up on Twitch, which I figure is the important thing to verify that it's coming out of Twitch correctly. So there's a few seconds between when I speak my test and when I get the results in my headphones. So that's what's going on. We are live. Let's do this. Today, we are going to finally, hopefully, fix our transforms. We know what the issue is, thank goodness. I think. Just didn't have time yesterday to do anything about it. And then we'll start doing batched texture quad rendering so that we can finally replace our buttons. So the buttons I've got right now look like old school, like Windows buttons with a gray, raised, beveled, rectangular buttons with a hover action and a hover and a active state, up and down state. We're going to replace those with something with some icons eventually, but let's get into it. So we are finally going to fix this scaling rotation issue today. I think we know what to do. Batch texture quads. Depending on how long that takes, we may look at some sprite sheet stuff. It's very similar to what we're going to do with a batch texture quad. Well, is it? I don't know. We'll think about it. Oh, we already did this one. We did that yesterday. Or is it add cheat? Yes. Good. So we can cheat now. Yeah, overall, good progress. Good progress. All right. So here's what I'm looking at. When I've been building up my vertex buffers, I've been putting the value in here that inverts my y coordinates for me. So instead of this being 0, 0 in the first vertex, it's actually 0 and then the viewport height minus, so that the y coordinate is flipped. Which is why I think our rotations and our scaling are wrong. So we need to change a couple of things here. Let's go to application real quick, and instead of loading into main menu on startup, we're just going to skip straight to the about scene. Oh, just about. Nice. About. Which would save us some clicking around. And then in the text quad, this is where we're going to be working. We may have to do a few things like changing our UV coordinate system coordinates. We may have to add an additional transform to our transform matrix to invert the Y. But let's do a quick build and just see what we're talking about here. Okay, we did a build in the top level, so it's regenerating all of our assets. Not a big deal. Gives us time to ready our beverage of choice. Get your tea, get your coffee, get your Monster, get your Mountain Dew, whatever the cool kids drink these days. I'm drinking yerba mate. Now we run. So this is what we're looking at. When it comes to translations, everything works great. But remember, I'm inverting the Y. So here in this corner, well, here, this logo. Here in this corner is 0, 0. And then negative, and then positive Y goes down, positive X, negative Y, negative X. Okay? So the transformation works fine because we are taking that transformation inversion into account in our vertex buffer. But when we add that transform into our vertex buffer, we get this additional Y offset. So instead of this scaling about its own 0, it's scaling about a 0 that's somewhere down below because we've inverted the Y inside the vertex buffer, not inside the transform matrix. Same thing with this rotation. Instead of rotating around its 0, 0, it's rotating around some point that's offset by that much, right? So that's our problem. And if we remove text prod, so instead of inverting it here, we're going to go with the positive height right now just to see how that looks. I'm just going to see what it does. Are you making a game, Hazel Kate? Yes, yes, I am making a game. So, yes, right now we're looking at our transformations, but the game itself is fully functional. So we see what we're doing here real quick. So that everything's upside down. I don't know where the other stationary box went. Yes, if you want to see the game, let's go into application and load into the main menu instead of my sandbox. I probably should create a sandbox instead of dumping everything into the about scene. If we build this real quick, I'll show you the game real quick. So the game, there's 3 game modes. You try to deduce words. So marathon is deduce as many words in a row as you can. Sprint, get 6 words deduced in 6 minutes. Get the 6 words deduced in the shortest time possible, and golf, deduce 9 words in the fewest number of guesses possible. So if we go to like sprint mode, texture quads are all upside down. So let me go fix that real quick. So that puts us back to with some issues in our transformation code. There we go. Then people say it's like Wordle. Actually, it's a blatant ripoff of 1992, somewhere in there. Word breaker. So there's no positional information, just the number of characters that match. That's all you get. So we know that demon has no letters matched, lines has no letters matched. We know that P and R both have to be in now. We know that U has to be out. We know H has to be out, so C is in, A is out, T is in. And there's my extra letter. It's got to be Y, right? 1, 1, 2, 1, 2, 1, 2. Script. There we go. And then you get a new word to guess, and you get less guesses until you're down to 10. And that's the game. You do have these deduction workspaces, so if you've made some deductions up to some point, maybe you decided this, you can copy those changes into workspace, into a journal 2, or you can just have a separate workspace where you do different things. So you can experiment and try things out and have 4 different workspaces to deduce in. That's basically the game. So back to what we were doing. Text quad. Let's just copy this so I don't have to keep manually editing things. Okay, so 0, 0. We went with positive height. It didn't look very good, so let's just try flipping the height real quick. See what that does. Oh, they're just gone. Okay. How's everybody doing today? Okay. So this is oscillating between 0 and positive something. It'll be about seen on update. It's going from x is 10, and then it goes from basically 0 to 30 pixels. 30 pixels down puts us off the screen. But I still want that invert. So, and these other quads that we were looking at are probably down here somewhere. So, in our thing here, we first scale things, then we rotate them, then we translate them. What if you just invert the Y? Is that everything I need to do? I doubt it. That sounds too easy. So right now the math is making sense. Nope, it's gone. And I don't know where it went. See. I thought I saw something in one of the open tabs last time about let's take a look. OpenGL transform to invert. blah, blah, blah. A scale and a translate are required in that order. So the translate, well, the scale. Do we do that after everything else? Do we have to scale translate again to invert? So we scale 1, 1, minus 1. But then we have to translate everything by the height of the renderer viewport height. Then we don't translate on the z-axis at all. So my question is, where do these two lines go in the transformation stack? So we're going to use our raw data, our raw vertex buffer to scale the mesh, rotate the mesh, translate the mesh to where it needs to be on screen. So maybe we do this first. That's like a little trial and error first thing in the day, right? Oh, okay. So everything we've done puts everything right back where it was. That's unfortunate. So if I don't do this extra translate here. Oh, wait. Right, so if we put these after everything else, we're saying compute the final screen space, and then we flip it and add the height of the, maybe it's an order thing here. I felt like that was really close though. Okay, so now we're going above, and I don't know where the other quads are at all. Feels like it's just an extra translate. Okay, this part we know is good. And our textured quad just contains the rectangular data, no offsets built in. I was really hoping one of these combinations would just be the answer we're looking for here. Inverting y-axis. Oh. Surely someone else has tried to do this exact thing. But Google often lets me down. Not often. It's usually the most popular answers are the beginner ones because they're the ones asking the most questions. Translate scale. That's honestly the best answer we've got. Could flip the camera. There's some very bad advice in this. In the intro Googles. We have to change the camera. I'm being told that is the way to do it. So if we go to the About scene, We have a screen camera. XY width height. Set viewport. Is that it? Oh, or it's here. Let me set the viewport. Do I also have to change it in the projection matrix? Try it. Okay, so that doesn't work. Okay. Make our projection negative. That's always the option. Gonna try every permutation until we figure something out that works. It worked. That's now zooming in and out of 0. This is rotating about its origin, which is about here. This one looks stupid. But why is that? So 0 is still here. This is 0, 0. So it should all be up higher. Okay, so we are super close. Because we inverted that Y there. Is that it? All we had to do is flip our camera? That would actually simplify things a ton. No. Incorrect. Viewport, no, under viewport h minus y. If that's it, then I will be super happy. Nope, that was not it. Dang it. super close. Yeah, or just the X. Plus the viewport renderer viewport dot h plus y. Now we've changed our camera, I have to rethink through the whole projection thing. Nope. Minus y. Oh. Invert the viewport rectangle height. We don't need to translate anything. Ortho. GLM ortho. Let's give that a look up. GLM ortho. Is there like a simple docs page? Why is that not near the top? Ortho is just X width, Y height, I think. GLM, so here we are. Left, right, bottom, top, near, far. So in the first place, we did not put that. We've tried this one. It's close. Or we could flip it this way. Each one is going to give a slightly different result. Okay. So now it's telling me that the 0, 0 coordinate for each of these is here. Here we're oscillating between 0 and 30, which is the right direction. But the y coordinate for these things should be this corner, not this corner. They're flipped upside down, but I'm less concerned with that. Translate, rotate, scale. The positions are correct, but it's using the wrong coordinate. So we can look at x quad. What if we invert the y there? Okay. All is well with the world. This is perfect. Thank goodness. This is the transform we need. We found the secret sauce. So every other object we have that has a vertex buffer, we need to get rid of those hard-coded viewport offsets, and we need to make anything relative to the height negative. And then we should just be back in business. Because these translates and scales are perfect. Affine does have a center about which we can rotate and scale, which is not being applied. So let's get rid of these ones because those don't matter anymore. So in theory, I think it's like that. Center. Did I not set center? So center is 0 by default, if I'm not mistaken. Yep. So in the about scene, we're setting them with 100. Oh, interesting. $50, $50. 2, 3, and 4. We're just going to see what that looks like. It is definitely not scaling about or rotating about the right. Actually, the X looks right, it's the Y. So we go to this. We have to flip the Y here as well. So this gets minus Y, this gets plus Y. Oh, perfect. We have zoom, we have scaling and rotation about an arbitrary point relative to the 0, 0 coordinate of your texture quad. Hallelujah. Now, the one last thing. This translate should probably also use the center. So if you have a point about what you rotate, don't you want that point to also be what you place it by? Basically becomes the focus point for the texture quad. Oh, it's like that, is it? Okay. Which means we'd really want it to be the dough to be cut off halfway here and then drop down 30 pixels and then go back up. No, we can position it by the upper. I'm fine with that. I think we're done. That's our transformation matrix. So we translate by the amount to the center, then we can scale, rotate, and then put it back where it originally was, and then make the final translation there. Or do we double translate by the center so that so if the center is 0, 0, right, which is the default, you'll rotate around that upper right hand corner or upper left hand corner and position it by the upper left hand corner and scale around the upper left hand corner. I need to decide that. That's important enough to warrant some thinking. Our theta, here's our GL3. Because when I think about placing a UI element, I think of placing the upper left-hand coordinate. But I like to rotate about other points. Transfer still relative to 0, 0. So basically what I'm talking about is we'd have to do this translation twice and this one once. And then the center, the position you set is at 0, 0 plus that offset. So it would look like, oops. So this one, oh, that's not even where I want it. That one has to be, doesn't that negate the other one? Oh, which actually would kind of make sense. Yeah, now 0 is here at the center of the, oh. Okay, what if we never take this, factor this one out? Is that what I mean? Yeah. So basically this is now 0, 0. So here is 0, 10. And then it goes down 30 pixels and up 30 pixels. Is that what I want to do? It's a debate. A debate. Anyone have strong opinions in the chat? Rhizoma, I know you have good ideas. You know stuff. We've worked out our projection matrix. We've worked out our transformation matrix. We just have to decide which behavior is correct for translation. When I ask for the object's x-coordinate, that x-coordinate is where the center is. I think both are valid as long as you're consistent. Decide if center is also where an x and y are mapped to. If so, next line is commented out. Now, obviously, if this is 0, 0, it's the same as if you don't do anything. I think if you set the center to something, that's just where it is. I think we're going to go with this for now. Note, if center is also where mx and y are mapped to, next line is commented out. Okay, I think that's it. So if we go to screen camera, those go away. X quad. These all go away. And I've left absolutely everything else broken. So let's do this. Get status. Get commit-m. Translation, rotation, now working correctly with respect to the screen space. I prefer with text quad. Test in about scene. Need to update all other vertex buffers before game will work right. Okay, so we've got a safe place where we can always come back to. We have text quad. Let's go fix color quad. Because there was one in this scene. So set everything relative to a 0, 0. It's all been properly offset. So really, this should be 0, 0 no matter what we do. in theory. As long as we flipped the Y's, I think we're good. Let's just try it. See if that red rectangle shows up in that corner in the about scene. So use that color quad in the settings menu, settings scene. That's not what I wanted to hit at all. There we go. There's our red rectangle right where we'd expect it. We are going to make a couple of changes though to the about scene, or relay these things out. We're going to add the 50 to each of these. That we're offsetting so that they're more centered. T quad 1. This is setting it up in with the other quads, but the animation overwrites that. So instead of moving X, let's just go 200. About 200 pixels. We'll go 65. 65. Just to see what's going on. I really should have tackled this a lot sooner in this development process, but okay, so that's, yeah, so 0 is here. These are spaced out way further than I want. It's probably because of I added 50 to absolutely everything. Instead of 155, it should have been just 55. And Y would be up, which would be just 55. Quad 2, 155, 55. I think, yeah, just all the negatives are that. All the pluses are that. Ugh, of course, it's just going to be silly. Do I remember how this animation thing worked? This was like an animation test. How do I trigger that? Should I just think about this for a second? I take the center, I move half the width. Oh, yeah, I think this is it. So on do update, space starts the animation. No, T. Space resets the color. T starts it. Period. What does period do? Left bracket changes the easing method. Tab changes the animation method, whether it's with respect to time or with respect to the mouse's X position. X and Y, yeah, so this animation testing was all very complicated. So as long as it works. Okay, so T moves that. Space, let's see here, bracket. Change the easing to quad in, quad out. or quad in. Very nice. Quad in, quad out. There we go. Boom. Huh. How did I select different animations? I had some with like color things. Z. Oh. So Z. X, Y, Z, and slash, huh? So. Oh. Let's get my shell back up. So X, X, run it. Y, run it. I don't know. Z. Oh, I'm hitting reset, not start. So the color changed from red to green. Y, run it. /, run it. Boop. Perfect. Okay, so all the animations are working. This position is working exactly as expected, as are these ones. So that's good. I think that's all we can test in the about window. So git status, git add. That's not right. Git commit gem. Color quad brought up to speed with new coordinate system. And really that's not correct. So let's go to application. And we need to reload just the main menu. And we need to do color, batch color quad. It's going to need to get updated. Color quad, color batch quad, color quad batch. And right here, that actually is going to shrink my code quite a bit. I mean, code it's minus. So actually, this is h minus y. This is h minus y. Line code. Boom. I think that's it. Compile. Nice. Been going for what, an hour? That was pretty good. The text is not going to show up correctly at all, but the button rectangles should show up correctly. They don't. Where are my buttons? Because the button. Let's go fix the text. Oh boy. Set text, set font, set text size, alignment, render, update text. It's definitely what we're interested in. Current X, current Y. It's relative to x0, y. Okay. That goes away. Is that it? And wherever y is, okay. Can we try it? Does the about scene have a back button? It does. Okay, so we can actually test this in the about scene, which is good. We at least see things there. Um, what is that going to do? I want text to show up or a color batch color quad show up. That's what I want. The back button was down here somewhere, so it's not there. Neither are the color quads. Right here, set cog corners. I bet that's my problem. Or yeah, we give ourselves a couple of options for modifying. You know what we get? Hey, we got some of the color quads to show, and they even look correct. Not bad, not bad. except it's probably this one right here. X0, Y0. Here we are. Here's the viewports that wandered in. And just like before, we can flip the logic here. So it's R H minus R dot Y. Make it a little easier to read. That last color quad should show up. Oh, it's not right. Why is it not right? X0 is at X plus width, minus Y, plus height. Oh, is it minus minus? I suppose that's possible. Everything else is inverted, might as well, right? Boom, there's the button. Now we just fix text. Well, git status git add -a git commit -m. Color quad batch got up to speed with the coordinate system. All right, text. Let's see where this went. Rectangle top goes there. Button. Hey, there's my text. And it's all showing up right. Woo-hoo. Okay. This is good. I didn't like the way that I had to keep track of my viewport height myself. I just didn't think through the problem that much because I didn't have a workaround with manual adding. So next, source, multicolored text. Okay, we're gonna have some other issues we're gonna have to fight through, but we'll come back to those. Okay. Looking good. Good. At this point, I think we should be able to play stuff. Things seem to be working just like they always did. Good. No, you. L and S are in. No C, therefore A is in, no T. B or Y. False. Oh, it's not B. It is Y. Okay. I think we're in business. Everything's laid out fine. Awesome. Boom. Is that it? Okay, there's still one more factor to work through. Well, there's still two factors to work through. Let's check our journal. How are we looking? Journal. Fixed scale rotation. Let's just write down what we've been doing. Screen camera now defines why the screen space upside down. Vertex buffers all have negative y coordinates. Affine also has center working. Okay. So screen space, Affine transforms in alignment. That's not all though, because we have to do two more things. IntSpinBox, pass parent, child, transform. Instead of what we're doing now, needs to be done. The other thing we need to do is contains doesn't use transforms. Git status, git add, git commit, dash dash amend, dash dash no edit. Okay. Progress. I like progress. So we need to fix the IntSpinBox. What happens is we set the rectangle, and we update our child components. So we are placing the TextEdit at 0, 0, when if we go relative to our parent, it should be at 0, 0 relative to our parent. Same thing here. And here. when we render, we pass the parent transform through the child. The only place we can test that is in the settings window. So it's rendered in the right place, but it's not accepting the click, the mouse click. Okay, so perfect. That's a good test case. Application was not working about anymore. Journal. We do now pass our parent-child transform, and it does render in the correct place. Okay. Last piece of this puzzle. When we ask, does this rectangle contain things, it needs to know about its parent relationship. It needs to go to the parent and say, hey, what's your transform? And apply all of that transformation to the point we're testing. I think. Anybody done this before? The parent-child stuff isn't rocket science. Okay, good talk. The easiest place to test this is the text for the IntSpinBox. Okay, we now have parent-child relationships. Hooray! The IntSpinBox. Oh gosh, okay. Everything that inherits must also get a parent. So the IntSpinBox, the button, scale pointer, button IntSpinBox. Oh, let's see here. Text edit. Also need a parent. And actually, we can change text edit. Set rectangle. We move to there, we copy that thing. Oh, look, here's all those X, Y. We no longer need to supply those ourselves. There we go. Then, where we render, boom. I may have to think about this for a second. Eventually. We probably want to save ourselves the work, so let's get IntSpinBox back up. GLM mat for MVP equals. We just do the multiplication once. I'm sure that the optimizer would figure it out, but why take the chance? This just makes it very clear what we're trying to do. Not what I'm supposed to do. That's oh, okay. Text edit's going to get similar treatment. Underscore. 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 There we go. All right. Awesome. So text edit doesn't need this. How many other things do we comment out that we would like to remove? Yeah, to-dos, those are fine. I think we actually removed most of their junk. Yep. Okay. Where were we? You know what? Let's just go searching. Dash exclude their dependencies. Oh no. Should have done a clean first. Okay. Button we did. Some color quad. Let's just double check. Button H. You know what? Ooh, we have to update the button as well. Anyways, it has color quad needs to know all about parents. Okay. Color quad batch. Okay, IntSpinBox we just did. Yes. So button we might need to make a change to. Multicolor text needs parents. Text quad. And lastly, text, which we have not done yet. Oof, okay. I think so that everybody knows what the default is when they look at the source file, then I'm going to flip around all the different things. So color quad, color quad batch. I think that's it. I think color quad batch. More than that. What did we forget? We got text, multicolored text. We got color quads. We need text quad. text edit. Why did text edit not get in this? Oh, wow. Yeah, that definitely needs to be public. Okay, semi-major refactor, not a big deal. We need to fix button. So that's the last one. Oops. Text edit. Did not remove those. Okay. FPS label. Hmm. We're on a full clean debug. Yeah, let's just run a full clean, see if that cleans up things. So, the reason we're adding this parent-child relationship that can go the other way is that a child element has its offset relative to its parent's offset. So, if I click on like the up or down buttons of the IntSpinBox, those are not in screen coordinates that I'm looking at the local rectangle. So I have to be able to ask the parent, what's your transform? Apply that to myself and then ask if that point is inside the rectangle. So I have to be able to have the child ask the parent for their transform. Well, this is real. I'm going to take a short rest from. Well, no, it's just about done. Shoot. Okay. Oh. Okay. Now, all of this should still work as before. Yeah. Buttons and everything. Okay. But settings, this still isn't going to work because we haven't fixed it. So these things that have child-parent relationships, the actual text object I want to click on is not here. It's at 0, 0, it thinks, without taking into account the parent text edit object. Okay. One quick look into button. Set rectangle. Blah blah blah. So where do we set these x and y coordinates? x0 is 0. Okay, so this is already taking that all into account. Text set rectangle. Okay, so this xi0, xi. So x internal 0, x internal, y internal 0. Are the points relative to the button. So this is all fine. That's good. Okay. Did I miss any here? I did button, color quad, color batch quad, IntSpinBox. Did we get that one? Does that have parent relations? Equals no pointer. Text edit. All right, let's take a look at the whole list. That's where we grabbed. We got button. That has parent. Color quad, I'm pretty sure we did. Yes. Color quad batch. Parent is noted. IntSpinBox. Yep. Multicolored text. Yes. Texture quad. No. All right. Good thing we checked. Text.c. Yes. Okay, so as long as all of that files, we're going to call that a win. I'm going to take a restroom break, grab a snack, and then we will fix contains tests. Make sure it runs. Okay, there we go. Loom. Okay, everything is working as expected, including the failure in settings to register the position of these things correctly. We'll do that after a short break. So git status, git add everything, git dash -o, let's get the journal. In inheritors can. What else here? IntSpinBox and TextEdit. Pass the parent-child transform. Oh, this button? That's what I was looking for. Button. Render. Times transform. Yep, right there. So we can steal that from the text edit. For MVP. Just for consistency. Okay. Instructors of all inheritors. So that's done. There we go. All right, break time. Okay, we are back. Okay. No, what asks the contains question. So we're gonna look for it. Exclude your dependencies. Okay, button, color quad, IntSpinBox, multicolored text, rectangle, text and text edit. Okay. So let's ask button. Why are those? Just a moment. Phone call. Okay. So my friend that I took to the emergency room this morning now needs a ride back, but I can't leave my small children until my wife gets back. So I'm afraid I'm going to have to cut this stream short, even though we started late. As soon as she gets home. All right. First of all, let's go do a little bit of refactor here. Contains point. Firstly, color quad contains point with contains. Int spinbox. Okay, everything else just text editing. There's no way that that is the are the only places that's referenced. So let's find the rest. About scene. Okay, that's an application. We don't care about button. Might. No. Color quad game scene. the one we're most likely to have problems with. Oh, interesting. Just do a build and see, I guess. See who complains about the naming. Oh, Button does. Button complains. That's the only one? So, I think contains needs to change. We do not want to factor in the viewport. What we want to do is construct which is a GLM at floor transform. I think I have to invert the matrix. use Affine inverse. Go. Affine inverse of that. GLM vet for point equal it's going to be x, y, 0, 0. Then our target will be transform times point. Target x, target dot y. There's almost no way that I've got that right off the bat. Suggested alternative, just plain old inverse. And it blows up. Do a full clean. Sometimes that helps. Oh, dang it. Well, actually, that makes sense. I knew this. If parent is not equal to null, target.x, y equals target.y, x, y. So buttons with no parents should be fine. There we are. And the hover is looking fine. Settings. But these are not working still. That's where all the minus signs think they are and the plus signs think they are. Oh, the cursor is not working. I'll have to fix that later. But any button with no parent works fine. Okay. All of those buttons should have a parent. Huh. All right, alternatively, they have the order wrong. If it's row major or column major, I don't remember anymore. Oh, wait a second. So this is not quite right anyways. We'll talk about why in a minute. So if we have a rectangle at 0, 0, and it's 100 by 100, and we transform it some amount, and then we ask screen coordinates, are you here? We have to undo that transform. So it has to be the inverse transform. It has to be the inverse transform before we check. There's our XY screen coordinate. We apply all the same transforms backwards. So I guess here is a question. We would get a lot less. Set cursor index gets the text rectangle. Cursor move to it's all these. What was this plus 5 for? I don't remember. Close. X offset at character. Five. Yeah, so this, okay. X offset at character. Walk forward through the string. it's a space, we do things to it. If it's /t, we do things to it. It's a visible character. We get glyph info. Equals this stuff. How much it advances. Sub 0. Okay. Plus glyph width. That's the advance. Take into account alignment. Um, close. It's close. Do we really want to fight this right now? We were, first of all, looking at button contains. What's the best way to test it? If our parent is not null, we get the inverse of the parent transform. We get our point, and then we apply the inverse transform to the point. Change the order. I would not expect it still to be at 0, 0. So the question is, are those buttons being given their parent? I'll bet that's it. I'll bet in TextEdit, where it creates the this thing is really comprised of these 3 items. Text change handler. Okay. M underscore text this. M underscore rectangle of this. And M underscore color quad of this. That rectangle does not need to be initialized. Oh, there's the rectangle. And that shows the cursor. Cursor comes after cursor color. There. Those are the 3 objects that need parents passed in. IntSpinBox. IntSpinBox. Here we have 3 items. TextEdit. two buttons. So TextEdit and Button. TextEdit IntSpinBox. Button is really just a text and a color batch quad. So text this and a bunch of colored quads this. Okay, that may help quite a bit. Those buttons were not finding a parent because we didn't set a parent. No matching function for that thing. All right. Let's go clean. See what that does. Oh, okay. Some more gum. Is button not inheritor of that? Hmm. Okay. Oh, rat. If I want to set the parent, I have to set the font at the same time. I may change that one of these days. Make the setting of the font a separate action. It seemed so convenient at the time, but now I don't like it. Okay, settings. Oh. Hmm. All right. Here's what we're going to do. We'll go into the About screen. We're going to include IntSpinBox. Right after the button. let's set a rectangle equal to your frame width minus 100. Let's come down 10. XY width will be like 90. Our height will be, I don't know, 50. Doesn't matter. Not really. So put it in our sandbox where there's only one spin box to watch. As usual. Okay. Very quiet chat today. Usually I get one or two people popping in from time to time. Wow. Where's my spin box? Oh, it's not being rendered or updated. Okay. Oh. On render, temp underscore spinbox dot render. Spinbox, I'm 90% sure. Needs to be updated every frame. Okay. So here it is. These plus and minuses are obviously not working. Those buttons think they're over here. So, in button, that's not what we want to do. We want to say input. Get our input. Is key pressed. Mouse button pressed. Left. So when I click the mouse, I want it to log something. If log parent equals null. So we do have two buttons in this scene, one of which will say no and the other will say yes. Button pointer this. Parent is null. Parent else. You know what? We should just be able to do this. Let's see how that's looking. Okay, in this place, click. So there are two buttons which have the same parent, so that's your up button and your down button. And the back doesn't count. Okay. So it is getting something with the parent. So we should only get two buttons printed out now. If log from a point x and y to target x, target y. The other thing we really want is the button's rectangle. Which is this x, this y. 3, 4, y, rectangle dot width, rectangle dot height. We just want to see what all the answers are. Okay, now we're going to click the plus. Rectangle 0, 0, 25 by 25, that's fine. From my screen coordinate 1020 to, and it's being transformed to 0, 0, so that's not helpful. Same thing over here. Okay. I don't have a way to get the text. Should be able to do that. Sure, name underscore text dot text. Instead of pointer, we're just going to take the there we go. So I'll know which one I'm comparing with. So the plus I don't really need a parent. Here, compare plus with text equals 0. We should only see one button compared now. We'll flip those two since we're getting a 0, the inverse. Like I said, row column, major. Okay, so if we click the plus, we're still getting 0, 0. Interesting. Okay. Target Z GLM back 4. Let's see. I think they call it W, right? GLM back 4 members. W equals. Oh, W equals 1. Interesting. I may have goofed. That is a W. I forgot we're in not homogeneous. We are in homogeneous coordinates, but now this plus is 0. Well, all right. The point dot W. Plus. Well, shoot. You have an initializer that accepts 4 floats for x, y, z, w. You should not be zeros. I don't. Z, yeah, it's not in there. So why not? Where did those values go? These are the mysteries. Wow, okay. So GLM vec4. Vec3 equals. I shouldn't have to do that, but it doesn't matter anyways. It's still giving me the wrong answer. Equals GLM vec4. Our 2D point. Our 2D point definitely has some real values in it. So why is this 4 vec4? Why is it? Why? Why? Point dot x equals x. Point dot y equals y. Point dot w equals 1. We'll go ahead and be explicit about this. Float. Come on. What? This just doesn't make any sense. It said give me a vector c equals 0. What is wrong with that vec for? It's along so well. Just cruising. Everything was going well. Ugh. But now, for some reason, this vector will not initialize at all. Wouldn't even mind if the target was doing weird things, because at least we're multiplying it by a transform and maybe we got the order backwards. But point XYZ W should be perfectly predictable here, because we initialize it here. We declare it a const. Does that make a difference? Why is this vector not initializing with a real value? Yeah, it's just zeros. The mouse coordinate is 1001, 24. And then when we stuff it into a v vector 4, it's just zeros. And 0 times any matrix is going to give you 0. Why, oh why, okay. Clean everything. Debug it. Oh my. Really wanted to get a start on batch texture quads. Not gonna happen today. It's just zeros. Why is it just zeros? Code like, hey, call this constructor. I expect it to call the flippin' constructor, but it's just not. What is this garbage? Oh, I bet I know what's going on. Or, well, maybe I don't know what's going on, but these are vectors. Point 0.3 float. That could be part of my problem. Logging the wrong data type, it's going to give me inconsistent outputs, although the fact that it defaults to 0 is not the best. Okay. So I got the parents transform, at least it did something with it. Although, can't really call that useful. At least we have values. Okay. Whew. Okay, rectangle from this point to this 4 vector to this thing. Rectangles. Oh. Okay, first of all, X and Y shouldn't be a thing here. We're checking the local. Okay. Part 1. Part 2. Let's just invert these and just see what the difference is. And we froze up. Interesting. It short all the extra work there. So it won't affect any buttons except the one we care about. And it just doesn't work. Why? Good heavens. First of all, we always have our own transform. The question is, do we have a parent transform? We'll cheat for now. We know this is wrong. Button. We can't apply that 0, 0 rectangle thing yet. Okay, that actually did apply transforms to it. And 7733 might actually hit. Oh no, it doesn't. It's close enough. Okay. So what we have to do, then here, we need our local transform. Then we need our world transform. It will be a little different. If parent not equal to null pointer, return underscore parent world transform times my transform. Else, just return my transform. As long as you have a parent, it'll keep chaining them. Yes. So when you go to button, when they're asking about this transform, we actually want this thing's world transform. In other words, every matrix that's multiplied to create this particular thing, all the parent-child relationships, and then we invert them. So let's try that. Times. I don't know why that's an ampersand, but that's the way it goes sometimes, I guess. Refers to temporary memory. Except it's a const reference to my class member. Unless retain system number a const. So you have to check our transform, which could be dirty, which we'd have to update it. All right, about click. Things happened. What happened? Oh, we need to run that in the debugger. GDB args run. Let's see where it crashes. Out. Click. Okay. Seg fault, probably because of the stupid local memory. Backtrace, quit out. Process mouse menu events. We have the handler. La. Button, handle mouse press event. Contains this XY inverse we don't return a reference to a thing, rather we just return an object. And run it. About click seg fault. This equals 1. Well, that's awkward. If parent not equal to null. But this, whatever it is, this is 1, which does not look like a valid address to me. Do a full clean then. Okay. Maybe we change the word transform to local transform. run about click. Okay. This actually is very close to what we want. I'll bet that we were really close to 12 to 12 right there. So x, y. I think only the y is off. Oh, no, it's not. It is? It is not. Is it? Because I know on this click, where it says that the local point 1231, I know I clicked well within this rectangle. It should be like 12, 12 or something. So why is the y off? That was 11 and 12, and it's getting the offset. Where did it get 20 offset from? This is so close. This x looks about right. Like if we click on this edge over here, I would expect 24. Perfectly reasonable. 29. So let's try the very top corner. Very close to 25, 25, 23, 21. What about this bottom one? 24, 42, 141, 121. Where's that extra 20 coming from? 20, 20. That is really close though. So if we go back into button and we say, oh no, if log return something else, return something else. So like I said, this should be 0. This should be 0. We have some cleanup to do. Oh, we got bots in the chat. Welcome, welcome bots. Oh, I did a clean build. So basically, if log means not crashing anymore. About click. And 31 is outside of this. So there's two transforms that affect this button right here. One is its transform within this rectangle. So basically there's the transform to the IntSpinBox, which is from here, 0, 0, all the way down to 10 and some amount, doesn't matter. Then from here, there's an additional transform to there. -8, 20. So why are we off by 20 pixels? Somewhere there's a 20 pixel offset coming in. Wow. Let's do script comp. Maybe we can get some information out of the plus and the minus comparison since they are at different XY offsets. They have different transforms. So the results will be different for both of them. Out. If we click the plus, we say the plus is at 0.2525. Minus is also that same size, and its local rectangle is 0, 0. Here's our same from point. Those look both correct. The difference is this one turned into 1233. This one turned into 1258. Pixels off. Only on the y-axis. The x-axis is perfectly correct. And these are in the right direction. So like this plus button is y above this y. Okay, so we're going to go to application. It just loads straight in the About menu to save us some clicking. And we're going to probably break some things anyways. So we're going to go to button. Going to make this the simplest thing we can. Need both of those. This thing, we could probably simplify even this, but we won't. Let's have the target. This number. Simplifies a lot when you can. We should even be able to see during like a hover event where the mouse is, where the mouse registers as hovering. Oh, it's not. So what do those buttons think they are then? XY width height contains target XY. Ugh, this is so close. Right, let's put all this back in. This is not going to help. Click. Yeah. Completely wrong. not do what you want at all. It did click. What the? Sort of. So plus does contain it. Therefore, that's it. 1123. I still want to know where this extra 20 is coming from. No and no. No and no. Something strange. It jumped from 51 to 20 with one pixel move. Am I relative to the correct rectangle? Just a second. Okay. It's not just 20 pixels. There's something very strange. There's the hover event right there. Ah. It's correcting completely on the x-axis. As far as I can tell, this minus never gets the correct hover. It's never right. there's a 1 pixel jump from there to there. Huh. This button's not going to work at all. Actually, let's do that. Let's see what the back button says. Instead of the plus and the minus button. Just a moment. Okay, my friend has got an alternative ride from hospital, so I don't have to drive anymore. Okay. So that's good. I was gonna have to end the stream early after I'd already started it late. So, oh, that looks surprisingly pretty decent. Oh, it's not surprising. All these buttons should be fine. It's these ones we're getting strange behavior out of. Oh, it's not letting go of the event. Wait a second. Why was that not logging anything? That should have logged. Left button. Oh, because the parent's not equal. Oh, okay. So I'm saying if the left button clicks and it's the back button. Do those things. Okay. Oh, did I see Mickey and What's Up showed up? Cool, welcome aboard, strangers. So we have fixed rotation and scaling, and we're now applying it to all of our UI elements, which is working except for parent-child relationships, and it's so close, but there's a weird thing happening in the math. So if I click above, what we have is the button back printing out. Its rectangle is 0, 0, 250, 50. That's its local coordinate. So here's 0, 0 here. It's 250 wide, 50 tall. From the point on the screen that I clicked, which was up here. Contains equals no. Oh. You know what? we can simplify quite a bit here. There we go. So what we're trying to figure out is where our transforms are going wrong. That all still seems to be working. So if I click above it, I should get a report that says this rectangle at this point transforms into local coordinate space this x, y, and that y is wrong. Huh. But if we click inside of it, yeah. Okay. Oh, I wonder. Why? It's only the y that's wrong, but we are doing math that flips our screen's representation. I wonder if that's what's screwing us up. I can't just do straight math here. I have to do an additional transform. Okay, so here's the deal. In OpenGL, 0, 0 is down here in this corner. And it goes positive at y, positive x. However, when I define 2D screen space objects, I like to define them with this being 0, 0. Positive y goes down, positive x goes to the right. Now, our transform to compute the local transforms of these buttons is 100% correct on the x-axis. It's only on the y-axis it's wrong. And by the time we get down to this back button, like up here, we can get it to click way up high here, but as soon as we cross this line, it like pops. And then it won't click anything. This back button, though, says that the transformed y is much further down the screen than it actually is. This is only 768 pixels high. So in fact, we have a y value that much higher. When we print, tells me it's wrong. Fit Rioter, howdy, howdy, stranger. Welcome aboard. Are those glasses? Is that what that emote is? For like I'm watching you? Looks kind of like glasses. I can almost see it. I thought I expect maybe something more like this. /OO/. Oh, but you can't put the slash outside because that's a command. Oh, fun. Sorry. Just saying I like leaving one hand up. I guess I could see that. Okay. I'm not up to date on all the latest emotes things. All right. So our inverse transform is, I would say, close. Except our y-axis is wrong. So let's see. I mean, ultimately, this all boils down to basically these two lines of code. But to log things, we've broken it all out. I mean, is it just minus renderer? viewport height, or the other way around, rather. I don't think it is. I'm not sure where. So let's go back to this one. We don't care about that. So we're going to look at the plus and minus buttons in the spin box here. So let's put, we're going to have both of them log every button pressed to tell us what the transforms are outputting. What GPU do you have? Oh, it's a decent one. I spent a good amount of money on it. Oh, not that one. Where's my hardware specs? Um, okay, it's the NVIDIA GeForce RTX 3090. So I'm gonna click at the very top of the plus button, and the plus button tells me my rectangle local is 0025. The mouse in screen position is 1001, 1001, 12. So if I take this four-dimensional vector and apply the inverse transform that's applied to that button, I get 12, 22, 0, 1, which is, this is the x and the y. And this x, y is within this rectangle. So it says, yes, we contain it. But this 22 here, I was literally two pixels from the top of that button. So where's that extra 20 coming from? Then, if we move down, we're at 1125. And then if we come down even just a little bit more, look, it came down one more pixel, and all of a sudden our y was 51. So what happened between this point, where we're 20 off, to this point, where we're now like 50 off? We should only be, what, 5, 6 pixels in? So I guess 45 pixels off. And well, so that's this. Oh, okay. So plus button says 26. So what about if we click above it? The plus button is picking it up. So there's an additional offset being added somewhere. If we click way down here, here's the plus button. 695, that looks okay. And then the minus button should not be further away, it should be closer. Right? Let me think about it. we should be closer to the minus button than the plus button. So the y is all wrong. Okay, here's an idea. When we make this point its float of minus y, because we've had to invert other values before. Maybe it's just all backwards and upside down. Okay, so we'll click near the top of this one. Minus 2, minus 12, minus 17, 7, 18. So 16, 9, 6, 3, 1. And actually, looks very close, except it's upside down. Right, minus the target y. I don't like how fiddly this is getting. But we can generalize it. And we want to generalize it. So if we click near the top of this, 1 or 2 pixels down. Nope. 24, 19, 15, 8. Did I not build? So near the top, minus 3, minus 6. Because the vertices are specified upside down and they're flipped by the screen space, there is a screen space, an additional transform that we're not taking into account. Okay, so I'll bet that the mouse button needs to get that y equals render viewport 8 minus y. Let's see what that does to it. Because there's two things we did. in our screen cameras, so this is designed to set up a screen space. Projection, orthographic, is we have to set our projection matrix to have the height negative. That's what flips the camera. And I was not taking that into account, so hopefully this just fixes it. There's a screen point, a camera point, turn out the same. Okay, so, oh. Uh-oh. So that was not it. Ah, we should put this in here. So that's probably not it. Could go here. We either need to do it at the beginning or at the end of the calculation. So if we click near the top of this button, 1221 somehow is not contained. So if we go down, the plus should be at 1231, 1242. $12.11 to $12.33. So question is, why did 12.11 not, well, it's not changing it after the fact, aren't I? Any experts on screen space transformations to world space? Look at our world transform. That's basically all of our parent transforms all the way up the chain, which is why this button will work when these ones don't. This one has no parent, so it's just its local transform. These ones have a parent whose origin is here, but the x coordinates coming in fine. That's target y. Let's simplify my output a little bit. This hasn't been giving me any problems. From to let's keep this around just in case. Yeah, things factor a little differently, so ugh. Okay, so we're just going to start way up high. We know the x coordinate's good, so let's start at like pixel 2, 1. Come down to about the halfway mark. Then we'll hit the bottom. So we should have 3 clicks with plus, reporting near the top. 11. Oh, that's not 11. Well, it should be above the rectangle we're in, so that should be negative. Because we were above it. And we're below it, about halfway. 768, 350, 370, 380-ish. So that doesn't look too bad. And then 760, see, that's not right at all. So it's happening on my y-axis. Okay. It's time for a restroom break. Let's look at the plus button. Let's look at the back button. The back button has no parent relationship. So if we click below it, Our screen coordinate is 888, 763, close to the bottom. It is transformed to a very different number. If we click just above it, if we click halfway above it, so this should be, I don't know, 350 negative. And we click way up here. That's practically your that's not 768. Oh, well, okay. What if we okay, so that's the back button. Let's just do the plus button, the highest one in the scene. Okay, so this should be a small negative number, slightly above. It is not. Down to about the halfway mark, so it should be 350 something, right? I'll come way down here below. I mean, that should never be more than 768, so that should be impossible. Oh, interesting. Actually, no. Nope. This button is locally 0, 0. So up here, this button back should not be at 0, 0. Because back X and Y are defined some. Yeah, it doesn't have a parent. So when I put back in here, X and Y should be real numbers, not 0. You move it to some coordinates, save the rectangle. Oh, let's take this out now. We don't use it anyways, right? Underscore rect dot x and y are never used. So back should have something here. So why is back reporting 0, 0? It should not be reporting 0, 0. It's not being drawn there. It should have a real X and Y. Move to X and Y. Scene has a rectangle with some real numbers in it. We set rectangle. We move to, which is the this. Then we save our rectangle and say that flag is dirty. If the flag is dirty, blah blah blah, stuff kind of doesn't matter. So why is it reporting X and Y at 0? That should be impossible. These values are not actually used anywhere. We should physically set those to 0. So we're gonna go, but this is about back. So we're gonna go slightly below back. And those are positions. From 2. That Y just makes no sense. It's almost like it's and we fed it a negative Y once. This is the before we apply the transform, which is consistent with how we lay out our vertex buffers. We flip Y's in the vertex buffer. So if we click slightly below back, it's a negative number instead of a positive. Click slightly above, 7 pixels above. I could believe that. So is that it? So this is similar to the screen camera flipping width and height. This negative Y here, it's similar to what we have to do in our vertex buffers. So we have to do it at both ends of the transforms. If that's the case, then maybe we're good. All right, so we're going to click slightly above it. We're going to get -3. Click slightly below it, 51. Click in the center of it. Okay. So next thing is to try it against the plus button. And then if this works, we generalize it. Hoping that was it. Slightly above the plus. That is a negative number. Slightly below the plus. Yeah, I believe that 30 is more than 25. In the middle of the plus, 12, 13. Okay. I think we've got it. So, if we put a negative Y here and a negative target Y in there, this may do the job. Oh, oh, beautiful. So now these buttons will work, but not the text edit because we haven't updated that yet. So let's generalize it and put that in the text edit. Oh, thank goodness. So let's add some notes here. Invert the y representing the vec4 similar to the y invert in vertex buffers everywhere. Invert the, or negate, oh, negate, yeah, probably negate, not invert. Negate the y from the out, from the transform point, similar to the to account for screen camera inverting the rectangle y-axis. There. Okay, so this all works. It all boils down to 2 lines of code. All that screwing around. I think we got it. So what we actually really want is 2 things here. One, we set rectangle. I want this rectangle to get 0, 0. So then, anywhere where I have mrect, we actually have to test this a little differently. mrect.x. Yeah, we have to do better testing. We have to say x not equal to, actually, we can make this more intelligent. X not equal to mrect.x or y not equal to mrect.y. And we set things to dirty. And if mrect.width not equal to r.width or rect height not equal to r.height, then, and we can actually just set them width equals height. See, every time we mark things dirty, it has to recompute a whole bunch of stuff. So, the more specific we could be, the more efficient we can be in not updating unless we absolutely need to. There. If you change my x or my y, we have to do a move too. Set it 30. If the widths aren't the same, set the width. Right. Okay. So m underscore rect. Here. Height. So we can actually take mrect.x and mrect.y, because those are 0, 0. They will be by the time we're done. It's all look fine. By default, x and y are 0. Okay. So that should fix a lot of problems. And the last thing we want to do is in Affine transformation, we want to ask tool contains any old const rect reference and int screen x, int screen y. We can make this stat. No, we cannot make this static. And we cannot make it constant. So scale. Here. This basically gets all of this from the button. We don't create a new rectangle, we just want to ask contains this. There. Now, anything special in there? Screen X, screen F, wrong button. Screen Y. R.contains is going to check. Well, I mean, we can actually. That's fine. In button, we can just ask contains our rectangle x and y. Now we don't have to write anything in button. So let's test that real quick. If that works, we now have enough generalization to do text boxes and maybe we have to do a clean for that new function to show up. I hope it's that simple. We just changed our whole screen space handling today. That's mostly went pretty straightforward. The first hour was fiddling around with the camera and vertex buffers. Then a whole bunch of things we were able to apply very quickly. This last one is basically the mouse button inside of a rectangle question, and that has taken me way longer than it should have. Okay, button. Inherits from this class. This defines a rectangle, screen X, Y. So I don't think there should be a problem here where button always instantiates thing. Did I spell it differently? I suppose I had typos before. Contains. Button should know how to call this. This is in my parent class. Candidate is button's own contains function. I know I provided 3 because this class here has defined this function you say does not exist. And button inherits from that. Public contains. Is this not right? Those are both in the Affine transform class. Contains const rectangle reference int const rectangle reference int button inherits from this class. Button.cpp initializes the constructor. We're not overriding because it has a different method signature. What is going on? Why does it think there's no matching function? It can come on, button. Wow. It's not an overload. Oh man. Okay. Who are my experts of C++? To my mind, I am correct, and my compiler sucks. What if we do this? Return. This points to contains. Maybe if I make it a pointer dereference, which should be implicit in my button scoping. If not, I can cast it to the class that has the definition, but I shouldn't have to. That's the whole point of inheritance. I get all the methods declared in the parent class. This isn't even like complicated. like a weird inheritance structure. This is just straight inheritance. Hey. That's not safe. I should dynamic cast it, but you know. Oh, and now it's just drawn all over the wrong place. What? I do not like that. What is going on? This is the contains function. It has nothing to do with what's rendered. That's C++ experts for me, and it's just drawing in the wrong place. What is going on? Why? I don't understand. Why does it not have access to this function? I declared it as public. It's publicly defined class. Should 100% be available. You know what? Let's make it protected. Why not? Only classes that directly inherit should have access to that. That's more of a helper function. I should be able to move things without. Yep, that's all fine. Should have access to all this. Actually, this parent wants to be protected. We can make parent protected, maybe. Transform. We need to rename it local transform eventually. Open your release build. Is that going to change its behavior at all? I don't know what's going on. This is like the simplest inheritance. This is the only kind of inheritance I like. It's when it's one layer. I just inherit things that just work. C++. in member function button contains. I'm not overriding it. There's no override here. Okay. Let's rename it. But bool contains rect contains screen point. Let's go ahead and put that down in protected. I don't see any reason anybody should see it. It's below scale by, but before rebuild transform. I don't have any control over that. So rect contains screen point.
Stop screaming.
Let's just go all the way. Does rectangle contain screen point? Clean deep. Oh, that button calls this new one. Does rectangle contain screen point? Oh, no. Build it in debug mode. Oh, why, oh, why? That's the whole point of using C++. It name mangles the heck out of all of these method names so that you don't get these naming collisions if the signatures don't match. If the signatures do match, then it's scoped to a namespace or to a class definition. And even if they're overlapped, it should say something like, oh, hey, you should override this, or this is not a virtual function you can override, right? Those are like the kinds of things I'd expect. But this is just like, oh, I have no idea how to do that, even though it's in your parent class. Just because the name is the same, the method signature is completely different, so I'm confused. I don't know what to do. My compiler sucks. What is going on? There's button, and it worked. If the name is different, it works. Oh my gosh. In GCC, what a pile of crap. Unbelievable. Alright, well, whatever. but that's not where that rectangle goes. Oh. Set rectangle. So who calls set rectangle? Goes like this. This is the wrong rectangle we're checking against. That may help quite a bit. Oh, we did a clean build. Shoot. We're doing so good for like the first 3 hours of the stream. This last hour and a half has been me stumbling about, getting unlucky guesses. Which really just tells me I shouldn't have been guessing. I should have thought through it, but a lot of the time it's easier to think through the problem in code and just test and see what happens. You often discover how things work. But I think a couple of these may have been faster if I don't know. Our buttons are where they belong. They appear to correctly be registering my mouse position. Okay. Woo. So the things that are happening in button needs to be also handled by TextEdit. Do we want to abstract away the set rectangle? Let's move to this has dirty. I don't think I need that volatile keyword there. Yeah. Yeah, I don't need a volatile here. Interesting. So we have dirty in the button. So if you change the text, actually, does the button ever call that? I mean, it does. It does. And it's updated here. So if dirty, yes, okay. Dum, dum. We have 2 checks for is something dirty. I'm gonna rename a thing real quick. Is transform dirty. That's more descriptive. We call rebuild transform when something is dirty. Okay. So that makes me feel a little better. Let me text edit set rectangle. Okay, so the text edit puts all of the burden of keeping track of whether something is dirty or not in the text and in the color quad. Okay. Still, this is more similar to button here. We're going to do that. You don't have to do anything there. Then do that. We don't have to do the move to. We just set the width and the height. Because mrect is constructed with 0, 0. Anyways. Okay, now the contains, thankfully, should just be able to get the same thing from now magically everything should just work. I hope. Fingers crossed. Hoping to get into batch texture quads today. Not gonna happen now. That is, this is no longer const because we can update the transform. And I think it's worth it to not have that be const. Every time you set X or Y or rotate or whatever, it could recompute the entire transform. Or you can set the dirty flag, which means every time you ask for it, you have to ask, are you dirty? Then recompute the full transform. I think it's going to be faster if I just ask, are you dirty? Which means we can update our own status. So, error. Okay. Clearly not working. Although, who is even calling this? So it's if the color quad contains the point. So this is fine. Color quad contains, or what? Oh, okay, so this is interesting. Yes, this is actually very interesting. I mean, it's not that interesting. It's sort of interesting. A color quad doesn't have to be rectangular in shape, like a TextEdit or Button does. We can make them pyramidal, so forth. Trapezoidal, rhombular. So we are using a dot product method for determining containership. Okay. Let's see set rectangle and see what that does. Does this have a dirty quad? So it has two flags, one for if the quad is dirty, one for if the color is dirty. If we set rectangle, we're just, so basically we have a shortcut for put all four corners in actual rectangular relation, but we don't have to. I don't think there's a better way I could do this. That's fine. Okay. So this quad contains string point x0 int x or y0. I don't think this is going to be terribly reusable, but since we've put does rect contain screen point anyway. Oh, okay. We're gonna move. So many decisions. Color quad dot. We're computing this target anyways. Given x and y, none of this should be any different. Then x equals target dot x, y equals minus target dot y, and everything else is the same. We can try it. What? Oh, I know I. Never mind. I don't think I know why. Yeah, it's the same. Do I have to clean it when I change its constants? I hope that's not the case. Could be though, I guess. Click. Hey. I guess for some reason the cursor's offset is a little bit wrong, but we now have that working again. Therefore, yep, we can click in these, click in them. Very good. Okay. Okay. Now text dot h contains does rectangle contain screen point? Multicolored text is going to get some contains. What other things have contains? Contains exclude vertex. Button color pod. I guess text edit we got done. Rect. And IntSpinBox. Let's go to IntSpinBox. Oh, okay, a whole bunch of these are going to complain. Let's take a look. 1, 2, 3, 4 complaints. Okay. Who looks at IntSpinBox can return a rectangle. Multicolored text can return a rectangle. Text and text edit. Why? How much does that bring things? of 2 does not invalidate any of my vertex buffer data, whereas width and height would cause a resize. But the child components handle that. X. Okay, so literally, my rectangle should stay with 0, 0 forever. This rectangle right now is useless, nobody uses it. Pretty sure text does get. Oh, but we could be smarter about this. What time is it? Almost 6. So I've almost been going for 5 hours. Don't actually want this rectangle here. We have the contains. So if we remove this, how many things get broken? I don't like this. Doesn't want the text rectangle. All it wants is the width. Literally just the width. Okay. Rectangle starts with 0, 0 by default. So we do need it for putting cursor in place. But we can be a lot more useful here. Const rect and rect. So we're not turning anything, we're changing. Okay. Okay. Here, we break it up. Set rectangle. Actually, this move too should not cause any change at all. Where did we copy this to? TextEdit? Nope. Okay, that all needs to go. Oh gosh. Oh, so much cleanup to do. I start at 1 o'clock, 6 hours. If I go too long, I have to split the video for. Okay. Oh, do I clean up outside of stream? I have not done any outside of stream on this project. Then we pick it up in the morning. This is like cleanup refactor work. Nothing too interesting, I'm afraid. But it's got to be done. So I think we're gonna kill the stream here, because basically our rectangle the whole meaning of it has changed since we've changed the way that our transforms are built and applied. So I think we'll finish up tomorrow with this refactor and applying consistent transform treatment to all of our different elements. I think so. Okay, in that case, thank you for joining the stream. Thanks for the comments. Thanks for watching. We will catch you tomorrow. Bye.